In this video, we're going to talk about a sample problem regarding impulse and momentum. Now let's proceed. A single gram mass is moving at 30 centimeters per second, while a gram of 4 mass is moving in an opposite direction at 50 centimeters per second. They collide head-on and stick together. Now we're going to determine the velocity after the collision. So we are given with 16 grams as your first mass and its initial velocity at 30 centimeters per second for its U1. M2 now will be represented for the 4 grams with its initial velocity prior the impact at 50 centimeters per second, but we're going to make it negative because opposite our left direction. Now, we are required to determine the velocity after the collision as variable v. If we're going to proceed now with the solution, we are going to illustrate the initial impact. Okay, we have your M1 and M2 with each other as head-on collision. For M1 with its U1 as initial velocity prior collision, and M2 with its initial velocity U2 going to the way of the first mass M1. After the collision, okay, both masses were attached as M1 and M2 with a single velocity after the impact. So how are you going to represent it numerically? The total momentum of the initial impact is equal to the total momentum after the impact. M1U1 plus M2U2 is equal to the summation of both masses or the masses of the first and second object, multiply it with the velocity after the impact. If we're going to solve the velocity after the impact, we have to plug in the values for M1 that is 16 grams, for U1 that is 30 centimeters per second, plus M2 at 4 grams, multiply it with its corresponding initial velocity at negative 50 centimeters per second, and then equate it to the sum of both masses multiplied with the unknown variable, which is the velocity after the impact. Solving now for the velocity after the impact, v, this gives us 14 centimeters per second. Now, thank you for listening. For other problems regarding impulse momentum, please click on the next video.